Yes. Okay, just email me what your question was, and I'll go back and fix it. All right, so we've got 2x plus 5 to the fourth minus 2x plus 5 to the third equals 0. The way I see this, you could do it a couple different ways. I think probably most people get this thing working. Awesome, it's not. Stand up and do it. All right, so you got two options here. I think the first option is maybe not as easy to recognize what's going on here, but what do both those terms have in common? 2x plus 5. And how many times? 3. They have a power of 3 in common. So if I do this, I'm gonna go 2x plus 5 to the third power. I'm going to factor that out. So if I factor that out of here, okay, what's that going to leave me? If I take 2x plus 5 to the fourth and divide by 2x plus 5 to the third, it's going to mean 2x plus 5 to the first. Okay, or just 2x plus 5. Okay. Now when I factor 2x plus 5 to the third out of 2x plus 5 to the third, that's going to leave me with what? 1, and it's going to be -1. And that should equal 0, right? So this gives me 2x plus 5 cubed and 2x plus 4 equals 0. So now if this thing out of the way. If these two things are equal to 0, doesn't it make sense then that 2x plus 5 cubed is equal to 0? Or 2x plus 4 is equal to 0? So this was going to be x equals -2. Okay. And now this one, how do I solve this one? What do I do first? Cube root both sides, right? Okay. So leave me 2x plus 5, cube root of 0 is 0. A number I multiply by itself 3 times to get 0 is 0. So now can I subtract solve for x? X ends up being -5/2. Okay? I think that is the maybe most abstract way, most complicated way of doing that problem because of this line of factoring right here. I don't think it's really easy for people to recognize that and see that. That I'm going to take this term and divide it by an expression to a power. Okay, usually we like to factor out GCFs that are single monomials, right? Okay, whether it's like 2x squared or 3x squared or 3x to the fourth or whatever, something like that. So let's do it this way. Can we go back through and say, we say that u is equal to 2x plus 5? Would that then give me u to the fourth minus u cubed? Does that make sense? Okay. We can, whenever you want to, throughout the entire year, throughout your entire high school, college, mathematical career, whatever you want to do, whenever you want to make a substitution that makes the problem easier, you can do that. Okay? As long as eventually you come back and back substitute that back in. Makes sense? Okay? And of course, as I say, we do this all the time. Okay? It just makes things a little bit more convenient to work with. So now we can rewrite this as it's the same process. We're going to factor out the common factor. The GCF now is u cubed. And that's a little bit easier to factor out than the 2x minus 5 to the third, right? Or the 2x plus 5, yeah, to the third. Okay? So I factor out a u cubed from there. I get u minus 1 is equal to 0. Okay? Well, that tells me that u cubed is equal to 0. And u minus 1 is equal to 0. So u is equal to 1. And u here is equal to 0. Okay. But now, once we've solved for u, we're going to come back up to that and make that substitution. So we're going to say 2x plus 5, and for that u, and then 2x plus 5, and for that u, and if you go through and solve those again, you still get that negative 5 halves, negative 2. Does that help with that? Okay. Same thing on the question that I was going to do above that, this question here. Okay, it's the same idea. Okay, it's really hard to use our procedure of, you know, two numbers that multiply together to give me 54, add to give me negative 15, and to keep in that x plus 1 there. I visually have issues with that problem. So I'm just going to write it as u squared minus 15u plus 54, where u stands in for x plus 1. I solve for u, replace x plus 1. And that's the safest thing to do. Hopefully you're recognizing that that is a quadratic format, right? Okay. It's just not the one we're accustomed to, the one that we see the easiest. Any others? See you? 5? Find all real solutions of this equation. All right, so if I'm going to start finding solutions for these things, I have to get it equal to 0. This thing's terrible. Okay. If I want to get it to, any time we ever want to look for solutions, no matter how large the degrees are, we want to get things equal to 0. So I'm going to move the x squared over. It gives me x cubed minus 7x squared. Oh. Should be 8x squared, right? Okay, I'll move the 1 over, so plus x, and then minus 8 is equal to 0. Okay? Now, we probably have a limited experience with factoring cubics. Okay? I would say that the type of cubics that you guys are most familiar with, maybe factoring, would be maybe something like this, where they all have an x in them, right? And you factor that x out, and then what's left over is a quadratic, right? And then we know we have a good experience with quadratics. This one you can't do that, because this one, all 4 terms don't have an x in them, right? So you run into a problem. The first thing you want to do when you're trying to factor a cubic, look at a GCF. All 4 or 3 parts have an x in them, take it out. Okay, and that makes things a little bit easier. If that can't be done, you hope that there are 4 terms. Okay, in this case, you got 4 terms, right? The procedure then, if you have 4 terms, is to take the first 2 and group them. Take the last 2 and group them. One factor by grouping. Okay. So what can come out of the first 2? X squared. That's going to leave me x minus 8, right? Okay. And then what can come out of these back 2? Yep. You get that. So now I get x squared plus 1 and x minus 8. So this is going to give me, when I solve that, it's x squared is equal to negative 1, right? X is then equal to square root of negative 1 is plus or minus I. And then this one, x minus 8 equals 0, so x is 8. The only thing here is, what did the directions say? Type in all what? Real solutions. Which one up there is real? 8. Okay. That's kind of the hierarchy that we use for factoring cubics is see if there's a GCF. Okay. Hopefully it's variable, meaning that there's a 2x or a 3x comes out every single term. Okay, and that will then reduce what you have left over to a quadratic equation. You can factor that. The next route to go is hope there are 4 terms, and then you can use this factor by grouping technique, okay? And if that doesn't work, you don't know the technique to factor yet, okay? We'll talk about the, hey, you do. You guys ever heard the rational root theorem? You talk about that in this whole class? P over Q, or hear those phrases? Synthetic division, we did a little bit of that last year, right? Okay. So we'll do some of that stuff. That's in Algebra 2, maybe a building block to get us to this point in this class where we can factor everything. And we use a lot of synthetic division, long division to do that. But we'll have techniques here to address this maybe a different way. This is obviously maybe the easiest way, though. All right? Any others? 8? Somebody say 11? 10?
8 and 10.
All right, with equations like this that have a square root plus square root equation, you need to do what first? Yeah, you need to get this by itself, don't you? You want to square things. That's the overall task of getting access to that x underneath the radical, right? Okay. But I can only do that if that radical part is by itself. Because if I just start squaring right away, I kind of see what happens here. I'll go through this quick. If I square right away, start squaring right away, first times first, we'll make that go to 7 minus x. Last times last, we'll make that 3 go to 9. But then O and I is going to give me, when I multiply those together and add them together, it's going to be 6 radical 7 minus x. When I square it there, yes, the original first term disappeared. It did make that go there, right? But the O and I product, or I guess the O and I sum, gave me the same radical back. It didn't alleviate the problem, right? Okay. Just kind of gets me in a bigger issue. So what we want to do to eliminate that is move the 3 over first. So I get 7 minus x is equal to negative 2 minus x, right? Now square both sides. Square that side, square that side. So now it's going to give me 7 minus x over here is equal to negative 2 squared is 4. Okay? I'll multiply these two things together, so it gives me 2x. And then double it, gives me 4x. Okay, you guys remember doing that in the schools class? If I have something like a plus b squared, that's always a squared, and then b squared at the end. And then you multiply these two things together and double it. Should I be? It's kind of the general form for squaring something real quick, a binomial. And then negative x squared is going to give me positive. And now I have a quadratic equation. I can set up equal to 0 and solve. So add x to both sides to give me 5x. I'll have x squared. Just going to rewrite everything over on the left-hand side. So x squared, 5x, and what? Negative 3 is equal to 0. And now how, I'm not going to go any further with that, but how would you solve that now? You have to use quadratic formula. Okay. And when you're done, because we squared things, okay, you're going to get 2 answers, correct? Okay. But remember, when we square things, we potentially create extra solutions, right? You have to take both answers and plug them back into the original problem to see if they work. And actually, let's actually do that, because I want to show you how you can quickly do that with your calculator. So let's go opposite b, negative 5 plus or minus 25 minus 4a c all over 2, right? So I got 24, 25 plus 12, right? So 37. So I get negative 5 plus or minus radical 37 over 2. Now, a lot of times on the website, if you've missed the question, if I go back to the website, it'll probably show you the key this way. So what they've done is they've factored out a 1/2 out of what I've got here. Okay? If I do that, factor a 1/2 out of negative 5 halves, it gives me negative 5. Factor out a 1/2 of radical 37 over 2, you get radical 37, right? Okay, so that's what they're doing. But using my calculator to see if these solutions work. Okay, there's a couple different routes you can take here. For 0, so I'm going to put in square root of 7 minus x. Okay, plus 3 minus 1 plus x, and you can do the combining of like terms and all that kind of stuff if you want to, but or let your calculator do it. Okay, but all I did is I moved this 1 over and I moved that x over, right? Okay, and I got the original equation to be equal to 0. So now I'm going to go back to my table. So go second table. And I'm going to type in those two things again. So I'll have negative 5 plus radical 37. Divide that by 2. And you see there you don't get 0, right? Okay. But if I try negative 5 minus radical 37 divided by 2, I do get my 0. So that tells me that the negative one was the one we want to keep, negative 5 minus radical 37 over 2, and the positive one was the extraneous solution, the negative 5 plus radical 37 over 2.
I was able to follow you with like graphing and creating the table, but how do you put it like that equation find things?
How do I type it? Like, okay, I'm gonna go down to, so when you go to your table, does yours kind of autofill everything? Okay, so go to second table set, which is your window. That's actually the window button. And we're going to go down to the independent variable, and we're going to go over and highlight ask. And then when you hit second table, your table should probably be blank. Okay, is it? Okay, so now and you're going to, I like to keep mine on ask. I don't like how it autofills because I'm never really interested in that. I'm usually interested in values that they don't autofill it with. So I'm going to, every time I rewrite another equation inside y1, those two values that I've already typed in are always going to be there until I highlight them and delete them. And then you can start over fresh with those quantities. The only thing you got to understand is order of operations. If I just go negative 5 plus radical 37 over 2, okay, order of operations is going to do that first, right? Okay, then it's going to add the negative 5. We don't want that to happen. We want that to be added first, and then take that sum and divide by 2, right? So you've got to have those parentheses around the negative 5 radical 37, so the order of operations gets done correctly. There are other ways. They're on the calculator. There's, to do one task on the calculator, there might actually be 3 or 4 different routes you could take. Okay, so that's one technique. Maybe in another problem, I'll show you a different way you can basically use substitution to check. Because that's all that is, right? Your calculator is substituting your x value into y1 and seeing what we come up with. Okay. Number 10, another good one. And we'll stop after this one. And we can ask more questions on Monday if you want to ask more questions on Monday. But this, and I guess, I don't know if we need to go all the way through this one, But is this term here, that variable term, is its exponent half of that? So they're in a ratio of 2 to 1 to one another, right? So they're in quadratic form. All right. My suggestion to you is let u equal x to the 2/3. Okay. If I do that, then u squared would equal x to the 2/3. I put that in there. Would be x to the 2/3 squared. Does that make sense? Okay. Well, x to the 2/3 squared is x to the 4/3. And you usually wouldn't write this, but I'm just showing you that if you let u be x to the 2/3, u squared then becomes x to the 4/3. You can make a substitution for that thing there, and you can also make a substitution for that thing there. And they conveniently substitute to u squared minus 7u plus 10 is equal to 0. Okay? If you recognize right off the bat that these are in a ratio of 2 to 1, as their exponents, you don't need to do this step. This will always work. You always get a u squared is equal to that first term. But I just wanted to do that in math to show you that it does actually work in this case. Okay. Can you factor that in? Yeah. U minus 5, u minus 2, right? U minus 5, u minus 2, equals 2. So u is equal to 5 and u is equal to 2, right? Well, what was u? X to the 2/3. And that's maybe where people are struggling on this question. If I go x to the 2/3 is equal to 5, and x to the 2/3 is equal to 2, right? What are we usually solving for in any algebraic question? X to the first power. So how can I make 2/3, x to the 2/3? What can I do to get that to the first power? I'm going to raise that to 3 power. Because then when I multiply, because that gives you a power to a power, right? And a power to a power, you multiply your exponents. That's going to give you 6 over 6, which is just 1. So let's go x to the first. And now I got to do the same thing over here, right? Okay, 5 raised to 3/2. Okay. And we'll talk about how we can rewrite that. You guys remember from Algebra 1 that if I have x to the m over n, I can rewrite that as the nth root of x to the mth power. Nth is a weird thing to say. Okay, that's how I can rewrite that. And you guys have seen, this is probably the one that you're most familiar with. If I have like 9 raised to the 1/2 power. Well, that is the same thing as saying the square root of 9. That should equal 3, right? Okay. So we want to do the same kind of concept up here, but instead of taking that 5 and raising it to the first power, what's going to happen is this denominator always becomes your index. Okay, and I'll have 5 cubed. Well, 5 cubed is 125, so I'm looking at the square root of 125. Okay, which that should be what? 5 rabbit 5. Okay. And then I'll do the same thing over here. I'll have x equals 2 raised to the 3/2. So I'm looking now at the square root of 2 to the 3rd, which is 8. And now we'll go down to 2 rabbit 2. That's 5 rabbit 5. Quick way of doing, we'll talk about this in geometry, a quick way of figuring out how to simplify radicals is to see what is the largest perfect square that is inside your composite number that will divide that composite number evenly, right? If they're going to divide evenly, then my quotient has to be at least a 2. Does that make sense? Okay. The only way that I can get a number to divide evenly to get me a 2 is if I divide that current composite number by something that is less than, equal to half or less than, right? So when I look at 125, okay, and I want to reduce 125 underneath that radical, all I have to do is check the perfect squares that are less than half of 125. Does that make sense? So look about, 62 look at 62, that's my cutoff point, right? Look at the perfect squares that are underneath it, which only gives me about 4 or 5. I divide those through, see which one is the biggest one that is inside there, and then simplify it that way. Does that make sense, everybody? I think you taught in Algebra 1, we did it in geometry, all that kind of stuff, but I think this process of prime factorization for us right now, and for anything you go in a class beyond this, this is too long, too overkill, right? Okay, we want to be efficient with the things that we do, so we don't want to have to do that. So thinking about how to do that process in a different way is a good thing to think about. Okay, and that's actually, if you guys understand the concept, the idea that I'm really only interested in numbers that are less than half that, because I need to get that at least that whole number of 2 as a quotient back. That is it's like a graduate level. It's called number theory. It's a graduate level course. If you understand that, you understand a great portion of that course, which is pretty cool, I think. So that's, what was that, question 10? Let's stop there, okay? So right now, tentatively,